A change in a product's price causes a movement along the demand curve. The demand curve in Figure 2.1 shows that if the price increases from $3.30 to $4.30, the quantity consumers' demand decreases by 20 units from 220 to 200. These changes in the quantity demanded in response to changes in price are movements along the demand curve. The demand curve is a concise summary of the answers to the question, what happens to the quantity demanded as the price changes when all other factors are held constant? One of the most important empirical findings in economics is the law of demand. Consumers demand more of a good the lower its price, holding constant taste and prices of other goods and other factors that influence the amount they consume. Superscript 4, it reads, in Chapter 4, we show that the law of demand need not hold theoretically. However, available empirical evidence strongly supports the law of demand. One way to state the law of demand is that the demand curve slopes downward, as in Figure 2.1. Because the derivative of the demand function with respect to price shows the movement along the demand curve as we vary price, another way to state the law of demand is that this derivative is negative. A higher price results in a lower quantity demanded. If the demand function is Q equals capital D of P, then the law of demand says that d capital Q over d P is less than 0, where d capital Q over dp is the derivative of the capital D function with respect to P. Open parentheses, unless we state otherwise, we assume that all demand and other functions are continuous and differentiable everywhere. The derivative of the quantity of pork demanded with respect to its price in equation 2.3 is d capital Q over dp equals negative 20, which is negative. So the law of demand holds. Superscript 5, it reads, we can show the same result using the more general demand function in equation 2.2, where the demand function has several arguments: prices of two substitutes, and income. With several arguments, we need to use a partial derivative with respect to price because we are interested in determining how the quantity demanded changes as the price changes, holding other relevant factors constant. The partial derivative with respect to price is partial derivative of Q, or italics capital Q, over, italics D capital Q over italics D P equals negative 20 is less than 0. Thus, using either approach, we find that the quantity demanded falls by 20 times as much as the price rises. Given d capital Q over dp equals negative 20, a small change in the price measured in dollars per kilogram causes a 20 times larger fall in the quantity demanded measured in millions per kilogram. This derivative gives the change in the quantity demanded in response to an infinitesimal change in the price. In general, if we look at a discrete, relatively large increase in the price, the change in the quantity might not be proportional to the change for a small increase in the price. However, here the derivative is a constant that does not vary with the price, so the same derivative holds for large as well as for small price changes. For example, let the price increase from P sub 1 equals $3.30 to P sub 2 equals $4.30. That is, the change in the price, delta P equals P sub 2 minus P sub 1 equals $4.30 minus $3.30 equals $1. The symbol triangle delta symbol, the Greek letter capital delta means change in the following variable. So delta P means change in price. As figure 2.1 shows, the corresponding quantities, capital Q sub 1 equals 220 and Q sub 2, capital Q sub 2 equals 200. Thus, if delta P equals $1, the change in the quantity demanded is delta capital Q equals Q sub 2 minus Q sub 1 equals 200 minus 220 equals negative 20, or 20 times the change in price. Because we put price on the vertical axis and quantity on the horizontal axis, the slope of the demand curve is the reciprocal of the derivative of the demand function. Slope equals dP over d capital Q equals 1 over open parentheses d capital Q over dP close parentheses. In our example, the slope of demand curve capital D superscript 1 in figure 2.1 is dP over d capital Q equals 1 over open parentheses d capital Q over dP close parentheses equals 1 over open parentheses negative 20 close parentheses equals negative 0.05. We can also calculate the slope in figure 2.1 using the rise over run formula and the numbers we just calculated, because the slope is the same for small and for large changes. Slope equals rise over run, which equals delta P over delta Q, which equals 1 pound per kilogram over negative 20 million kilogram per year equals negative $0.05 per million kilograms per year. This slope tells us that to sell one more unit, a million kilogram per year of pork, the price per kilogram must fall by 5 cents.